Good evening. Hi. My name's Carl. Welcome to Horizon Solutions. Who's been to Horizon before? Just a couple of you. Okay, great. Well, welcome. Horizon has been around for over 40 years, and we do a variety of different things. We do sound installations, we do video installations, stage lighting, and architectural lighting, like the lighting on the front of our building, things like that. And we do all kinds of weird and wonderful stuff. And we're pretty fortunate to be able to work with a lot of interesting people, and we work with a lot of interesting clients doing all kinds of different projects. Thanks for coming tonight. I know a lot of you are from OEART or from the MIA program. Try not to throw anything at each other. And there's some other people here from churches, that kind of thing. So that's great. Thank you for coming. I think it's going to be an interesting evening. Actually, first of all, I should ask, where would you put your knowledge about microphones? How many people here would say their knowledge about microphones and using microphones, whether that's for live applications or studio applications, who would put yourself maybe at around like a 3?
Hi, Logan. How are you?
Oh, sorry. Ha! Good. Oh, see? Students.
Nervous?
Very good.
Nervous?
Out of 10. Three out of 10. Who would put yourself
I think
around
you
a
can
3?
do great.
Okay, some honest people. All right. Who would put yourself around
Me
a
too.
5? Cool. All right. Let's say 7.
Mm.
Yeah. Anybody in the 8, 9 sort of range? Nice. Okay, we've got liars over here. So this is an unfair question. I have to tell you, we have a lot of different people who work for Horizon over the years, and I've had students come in from both OEART and from Fanshawe College come into our office and sit down with me, and we have conversations about how they would like to come and work at Horizon and do installation work, or they would like to come in and they would like to help us design acoustic treatment for system or for venues and that kind of thing. Does that sound cool? Yeah? Yeah, it's great. And I have people come in and they're like, yeah, you know what? I feel like I'm probably the top of my class. And I said, that's awesome. Where would you rate yourself on a scale of 1 to 10 in audio, in your audio knowledge? And I love it when people say they're 8 or 9s. Because then I turn to the guys like Paul Vroom at the back there who has, hey Paul, how long have you been working professionally in audio? 15, 16 years. Where would you put yourself on a scale of 1 to 10, Paul? 6. And I asked the same question to Don Clausen in our office, who's worked for Horizon for 35 years doing systems design of all kinds of shapes and sizes. He always comes back with 6, over and over and over again. You know why he comes back with 6? Because the longer you do this, the more you realize you know nothing. I would put myself somewhere in the area when it comes to microphones. Oh boy, I don't know, Adrian. Like 5, 4, maybe.
I think you should give yourself some credit.
I'm gonna say 4. Thank you. All right. So I think that the truth is that we've all got a lot to learn, and I think that tonight's gonna be a good time. The guy who we've got here tonight, Adrian Sterling, who looks completely different than the social media post that we put up, because that wasn't Adrian in the pictures. That was Jordan from our office here. But Adrian Sterling, he is with Gare Audio. Gare is the distributor for a lot of different cool products. They are the distributor for DPA microphones, of course. They're also the distributor for Meyer loudspeakers. So any Meyer loudspeakers sold in the country are going through there. And I know you immediately look. Don't look at those speakers. They're not Meyer. This is a Meyer speaker, though. They also do a variety of other things, including things like ClearCom, and there's a small manufacturer of audio mixers called Digico. They do all of those. What else do you want to talk about? Sound devices?
Sound devices, RME.
RME.
I should have made a slide for that.
Anything
There's 22 brands. It gets exhaustive, but we have a website.
There's a whole lot of different brands. And the thing is, they're a distributor. So you can't actually buy anything from Adrian, but you can buy stuff from us, and we buy it from Adrian. That's the way it works. But Adrian, Adrian's a smart guy, and he's got a lot of background in live audio as well as in broadcast, and that's part of why we thought he'd be a great person to come, bring him in tonight, and talk about these kinds of things. Whether you're here tonight, or you're joining us online, or you're watching this in 6 years from now, welcome, and thanks for coming. Almost everybody in the world knows this microphone. And when I say almost everybody knows this microphone, they might not know that this is an SM58, but when you say to somebody, draw a picture of a microphone, they always draw this mic, right? This is actually the 50th anniversary version of this microphone, which makes it kind of fun, and one that stays in our office, and we don't use it on any shows or anything. The sales rep for Shure said to me one time, you know, the thing about the Shure SM58 is that it's not the best microphone in the world. It's the most used microphone in the world, which means that if you understand how this mic reacts and what it's going to do, then you are starting in a great spot, right? It's kind of like you've got that favorite pen, right? Or you might have that favorite mouse or keyboard or whatever it is that it's just natural. You can just jump into it and you're good to go and you can work with that. That, for a lot of people, is the SM58. DPA does not build the SM58. They are a company that has gone and taken things and they're like, how far can we go? What can we do? How can we push this? How can we make things sound better, cleaner? Awesome. They do some really good stuff. And Adrian's going to talk a little bit tonight about DPA brand, but he's also going to talk a lot about microphones in general. And he's going to talk about, you know, the technologies behind these mics. I think you're going to have a good time tonight. If you've got any questions, then feel free to ask. We have, you ever seen this mic? Yes, some of you have. This is called a catch box. This microphone, if you have a question, we'll throw it to you. Just talk into the black part. It'll work, okay? Awesome. So, Mr. Sterling, are you ready to go?
Sure.
Everybody's ready to go in the other room? We think?
We think.
Yes, okay, great. All right, it's over to you, sir.
Thanks, Carl. Thanks, Horizon. Thanks to all you guys for coming. I am Adrian. We are, as Carl said, we're a distributor. We're Gear Audio. We sell DPA in the country. We sell other brands as well. This presentation, a lot of it is DPA branded. A lot of these concepts can be used with almost any microphone. The SM58 that Carl had here, as he said, is probably the most used microphone, as he said. And you know, there's the saying like, you know, you can put a 58 on anything. We also like to say that about our DPA mics, that we can put them on anything. This picture in my title slide actually is a picture from a show that I did for CBC at Massey Hall, actually, when we were doing their season launch. And pretty much every microphone on stage was a DPA, partially because I was the front of house engineer, but also partially because the CBC has decided to have a lot of DPA mics in their collection, so we're pulling from their mic kit, which worked out just fine. As Carl mentioned, the picture on the right is me. Some of you might have seen the picture on the left. I'm sorry to disappoint. This is this is Jordan. He's currently the bald white guy in the Caribbean lying on a beach, and I'm the black guy in London while it's getting colder talking about microphones. So I think you know, I think I won here though, because I get to spend the time with you guys. DPA, who we represent, was founded in 1992. Founded in 1992. It came out of a company called B&K, which makes a lot of measurement devices, and they are a worldwide leader in measurement and seismic recording equipment. And they had a collaboration with the national broadcaster in Denmark, where they're from, and through that partnership, DPA was born, and that's where DPA microphones have come from. I'm actually going to exit this presentation for a second because I just realized that my notes aren't up, which was, sorry, and again. There we go. Okay. Sorry about that. Let me get back to where I was. Perfect. So, we're going to talk about microphones. I know some people are more knowledgeable about microphones than others. We're going to start with the basics. We're going to go through some of my extensive slides, but we also have a studio in the other room, which we have a live feed to, and we have some examples that we're going to pull from. We have some microphones over there. We have some instruments over there. We have Logan, who is our great multi-instrumentalist, who's going to be playing some instruments over there while we demonstrate some techniques of microphone placement and microphone choice. But I think we need to talk about choices of microphones first and understanding how microphones work. So basically, microphones, in a very basic way, convert sound waves into an output signal, which is a DC voltage that goes down a cable. And there are a few different styles of microphone that do that. There's a dynamic mic, ribbon mics, and condenser mics. And when we talk about the different types, dynamic mics are the simplest design. They have a small diaphragm, usually made out of polyester. That diaphragm is connected to a copper coil, and that copper coil is forced by the sound pressure waves that address the diaphragm to go back and forth over a magnet, and that is what actually generates the electric current, the DC that goes down the line. Dynamic microphones are typically less expensive. There's no need for external power, so that's good. They're typically rugged because they're a simple design. There's been lots of pictures and videos and things like that over the years and stories about people using mics like SM58s for a hammer and then being able to sing into them because they would survive that. They are, because of their design, the least sensitive, but that could be a benefit because they're good in loud environments. They need to be extremely close to the source, and they have less high frequency detail. Then you get into ribbon microphones. A ribbon microphone is also, in theory, a dynamic microphone in that there are no external electronics, save for some special types of ribbons that we can talk about later. But it's typically a small diaphragm, still a copper coil, still a stationary magnet, and that sorry, not copper coil. That's a ribbon. My slide is incorrect there. But it vibrates the same way between the two magnets and creates a magnetic field, which creates the DC that goes down the line. Typically, ribbon microphones are expensive. They're very sensitive. They have really good high frequency detail. Phantom power, high SPL. There's a lot of things that can damage a ribbon microphone, and they're typically a figure of 8 style microphone. Then we get into condenser microphones, which are lighter, usually a gold-plated diaphragm. The diaphragm is located close to a fixed plate, and there's electronics in the microphone that require phantom power for that microphone to operate. That create the capacitance between the gold plate and the fixed plate that drive the DC down the circuitry. So that's another closer look. Some benefits to condenser microphones are they're more sensitive, there's wider frequency response, larger dynamic range, lower self-noise, and require external phantom power. And when we're choosing a microphone, we're going to choose a microphone based on a few things. Its dynamic range, its noise, distortion levels, headroom, polar pattern, and then how do we figure out what those things are. So the first thing we'll talk about is noise. All microphones have noise. We sometimes call that self-noise. You'll see that on the spec sheet of the microphone, but basically when you get into the noise level, that significantly affects the dynamic range because the dynamic range is what you can hear above the noise level, but before the microphone gets into distortion. So in a little example here, I'm going to exit this and go to Smart, and I have a noise generator running, and Paul has a 1K tone. So Paul, if you put that 1K tone up very um, doesn't have to be very loud. You can even bring that down a little bit. We know that that 1K tone is it's very apparent. We can't ignore it. It's there. Um, Now, Paul, if you bring the noise that I'm sending up around that 1K tone, if you have it. Oh, sorry. So now we hear some tone and we hear some 1K noise. We hear some pink noise. Um, bring the tone down a little bit. Okay. So now into a situation here where we have noise, but we also have a 1K tone. We're able to differentiate that we can hear both of those things together. Once the noise creeps up, if you creep up the noise, Paul, we should be able to get to a point where it's harder to differentiate the 1K tone. So we can kill the pink noise, and as soon as you kill the pink noise, that 1K tone is very apparent again. So that's something that happens in microphones. You can kill the, yeah, thank you. So that's something that happens in microphones. Start this again. That's something that happens in microphones, and we have ways to look at that. So this is a scale showing the self noise of a microphone being at 19 dB. The point where that microphone starts to get into distortion, we call that 1% total harmonic distortion. That's a point where we're able to actually hear that this microphone is starting to distort, not the preamp, not the signal chain, but the actual microphone. And then the space between where the microphone is starting to distort and where the microphone actually clips is what we call the headroom of that microphone. So if you look at this mic, this is a de facto mic. This is a mic that DPA makes. It's a very nice mic. It has very low self noise of 19 dBA, and it has a very high SPL before it gets into distortion, which gives you 120 dB of dynamic range. So a big dynamic range. If we get into another less expensive microphone, we notice that a couple of the numbers are the same. Both of these mics come from DPA. Both of these mics have vastly different dollar amounts assigned to them, but the second mic has a bit higher self noise. It will still go into distortion at the same point. It will still clip at the same point, but I have a smaller dynamic range. So when we talk about microphones and dynamic range, that's one of the things that we're talking about there. Directional mics versus Omni. We have obviously better feedback rejection with a directional mic. We can be in a room. I'm using a directional headset right now. I can be fairly close to the speaker without having the speaker feedback. I could also do that with an omnidirectional mic, but I'd have to be more careful. I might have to EQ it a little bit differently. I have off-axis coloration when it comes to a directional mic, and that's due to how it picks its direction and rejects sounds from other sides. It actually adds a little bit of coloration in the process of doing that. And again, this is across all brands. We have a thing called proximity effect. And proximity effect is basically the effect that when a microphone gets closer to a sound source, the low frequency of that microphone goes up. That happens in a directional mic. That does not happen in an omnidirectional mic. Then we have some different polar patterns, and I promise I'm going to get through this quickly, and we're going to get to some of the fun stuff. You guys can see those there. I don't have to read through them. And now we're at, I think almost everybody on the planet has seen this slide or something like it. So here we have a handheld vocal, and we have somebody holding the vocal microphone, and below it we have displayed the frequency response of what it's like holding that vocal, holding that vocal mic in that way. So there's a couple things we can do. One thing I'm going to do is we can actually demonstrate that by looking at that on an analyzer. I have Smart set up here that we can do that with the microphone here, and then we can also go to the studio and see what that sounds like with Logan in the studio. So I'm just going to, oops, sorry, I'm just going to switch over to Smart here. And, oh, sorry. We got that on the screen. So, I've got to, sorry, I plugged this out earlier to stop the pink noise. Forgot to plug it in. That'll take. So now we have, when I talk, you can see that the coherence changes because my voice is affecting the microphone's actually hearing it. But I'll go through and do the different patterns. So the mic's in free form. So we could see there that the high frequency of that microphone was greatly affected. I had to change the averaging to fast because it was too slow. It was set to a few seconds. We could see that the high frequency of that microphone was greatly affected by me grabbing that microphone in different places. The low frequency, not so much, because the low frequencies are long enough that my hand is not a big enough barrier to get through the low frequency. Now we can go to the studio and see Logan, and she should have another microphone like this, the 2028. We can go to Logan in the studio now. So Logan has a 2028 that we can bring up in the room. And then Logan, if you would mind going through those different patterns with us while you're talking into the microphone as well.
And kind of on the capsule, testing 1, 2, and then completely on the capsule here, testing 1, 2, 1, 2.
Right. So we can see that the low frequency is pretty much unaffected, and the high frequency is pretty effective as she moves through that. Thanks, Logan.
Yeah.
We can switch back to my computer, sorry. So we talked about proximity effect, and this is where we have the microphone moving towards the sound source, and we can see now by holding the mic, we were able to affect the high frequency, but not so much the low frequency. By moving a directional mic like this 2028, we're actually able to affect the low frequency, and the high frequency pretty much stays unaffected as it gets close to the sound source. So another thing for that, here we have just quickly here, I'm going to take this 2028 and I'm going to move it closer to the speaker, and it's a directional mic, and we should see the low frequency bump up a little bit, but the high frequency, uh, um, obviously it's all going to go up, but the low frequency is going to go up at a higher rate because as we get closer to the speaker. So um, what was a flat line was became very heavy on the left-hand side of the screen. But if I take an omnidirectional mic, like this iSemcom, which is also a measurement mic, I can do the same thing, which is why most measurement microphones are omni, by the way. I could do this. I could take the same thing, and you're not going to see the low frequency shelf up as much as the high frequency, as much as the previous example. So basically, until that went off the screen, it was still staying very flat going up. Whereas with the 2028, as it got closer to the sound source, the low frequency went up more. That's a product of that mic being a directional mic.
So, Adrian,
Mhm.
two things. One, that is in some ways a good argument for a microphone that's very close to the source, like an earset microphone, headset microphone like you're wearing right now,
Mhm.
for being omni. Obviously, you mentioned the one you're wearing tonight is not an omni, but there's lots of earsets that are omni, and that is a benefit that you're not dealing with proximity effect the same way, correct?
It could be a benefit. It could be a desired result
Yes.
as well too. So sometimes when we have, and we'll get into some of these examples, but if we have a directional mic, say pointing at something like a guitar amp or a snare drum, as we bring that mic closer to that instrument, we can get some more low end without having to do any processing or without having to um, add anything extra or tune the drum. We can actually move the microphone and have some drum tuning, basically just by moving the microphone itself. Uh, so we got into. Am I repeating a slide here? Is anybody into field recording or video capture or news gathering or anything like that? Okay. We have uh, also a type of a directional microphone is a shotgun microphone. And when we get into the shotgun microphone, I won't go through all the detail on the slides, but we get into the sound source entering the microphone on axis, and that sound source is unobstructive until it gets all the way through the tube and to the diaphragm. Along the tube, we have different slats where off-axis sound can also enter the tube, and that basically brings those on-axis sounds into the tube and into basically a labyrinth to delay the sound mechanically so that it gets to the diaphragm at a time when it will be out of polarity with the direct sound. And that's how we get directionality with shotgun microphones. Another thing about a directional microphone versus an omni microphone is that in some cases, in a lot of cases, the directional microphone has to be larger. That's why sometimes when we look at lav mics, we look at larger lav mics in cardioid than we do in omni, because we need some space to be able to do some of that cancellation, especially if you do it in an interference tube type of way, or if you do it in a dual capsule kind of way of cancellation, that also requires space. So even off-axis, response on a microphone is also really important, and we try to pay attention to that as well, because you cannot remove bad off-axis sound with EQ. And when we look at some of these microphones, this is actually DeVote microphone from DPA. But when we look at the very top curve, that's completely on axis, meaning that the microphone is pointing directly at the sound source. As we turn further away from the sound source, the next one down is 30 degrees off axis. Then we get to 60 degrees off axis. Then we get to 90 degrees off axis. We notice that the characteristics of that curve remain similar, but we lose amplitude, being the directional microphone. In some microphones, the characteristics changes vastly when you go off axis. So let's say you have a guitar amp on stage and the bass player wanders over to the guitar player to say something, and he trips over the guitar mic, and now that guitar mic is not pointing directly on axis with the guitar amp anymore. So not only did you lose some amplitude, but all of a sudden, what happened to my guitar sound? My guitar sound totally changed. Well, perhaps the microphone choice that you're using has a different on-axis response to its off-axis response. So now all of a sudden, yes, I've lost some level in the guitar. I reach for my gain and I gain it up, but I'm also reaching for my EQ and doing some other things to try to get that guitar sound that I had a second ago before that bass player tripped over the guitar amp. And all I'm thinking now is when we get back to the bus at the end of the gig, I'm going to slap him in the back of the head. So we'll deal with Mr. Bass Player later. But that's also important in other applications where you have multiple microphones together in the same place, because that's only one microphone pointing at one sound source. But if I have maybe a panel of speakers in a corporate environment, I have many microphones that are close together, and if I have not great off-axis response, there's no cone of silence around me. So this person's microphone is also hearing my voice. But if the response of that microphone being off-axis is different, it's going to cause comb filtering. Does everybody in the room, who doesn't know what comb filtering is? So comb filtering, that's great. Thank you. You know what? I've got something for you. I'm going to make this interactive. I think you said you knew what comb filtering was. Catch that. And I think somebody over here did. Did not? Did? Did not? Did not? Perfect. Here you go. So comb filtering is when a sound source arrives. My voice is arriving to you in the front row directly. It's also arriving to you at the front row from that speaker, reflecting off this table and coming to you, reflecting off this, well, yeah, probably reflecting off the ceiling and coming to you, off any harsh surfaces, probably not this fabric, but anything that's a hard surface. It's arriving at different times. And because of those different times, those waveforms will either sum together or they'll cancel at your ear. So if I have the reason that with those different arrival times is just because they're all coming from different places. If not only are they coming from different places, but they have different tonal characteristics, it makes my voice sound a lot different than it actually is. And that's what happens in a lot of times in panels where you have microphones with bad off-axis response, because they sum together, and some of those summations are actually cancellations. So the biggest thing that you're actually fighting when you put a panel of people with inexpensive lavs that have bad on-axis response and have some speakers close by, the biggest thing you're fighting is actually feedback. Because what happens is you have a lot of cancellations happening between those people, and those cancellations give you less level, and the promoter of the show is trying to tell the sound guy, hey, just turn it up, turn it up, turn it up. But the more you turn it up, the more you're actually canceling with the other mics. I went off on a tangent. I will try not to do that. The next thing we're going to talk about is stereo miking. But before we talk about stereo miking, I kind of want to talk about how we hear in stereo, and that's kind of an extension of what we just talked about just now about the sound arriving at your ear from different times. Most of us in this room have two ears. We have different arrival times from one ear to another ear, and that's how it helps us localize, tells our brain where a sound is actually coming from. So if I hear something, from in my right ear a couple milliseconds before I hear it in my left ear, my brain, which is much smarter than my conscious self, is able to quickly do that math and realize that that sound is coming from over there. There's also other cues that go along with that, because it's not just time differential, but my head is actually a barrier. So my head is actually shading the high frequency content of that sound source that may be over there. So not only does the sound arrive at this ear slightly before it arrives at this ear, but when it arrives at this ear, the high frequency is shaded off of it, and I realize that okay, well, not even consciously, my brain just tells me, well, that's a sound that's coming from over there. So by playing with time, by playing between my two ears, by playing with level, because also it's going to be slightly quieter in this ear than it is in this ear, and by playing with frequency, my brain's quickly able to tell me that this sound is coming from somewhere over there or somewhere over here. So knowing how we hear in stereo and how we do localization, we come up with a few different ways of doing stereo setups. So we have a few different stereo miking techniques, and we'll go through them now. So we have a setup for stereo called AB, or spaced. And what this is it's a spaced pair of omnidirectional microphones. The capsules are parallel to each other. This type of stereo setup is really good at reproducing reverberant sound. The advantage of the Omni is that, as we talked about with directional mics, we had a lot of proximity effect. We have colorization. By using Omni microphones in a spaced stereo setup, we get a more natural and more full low frequency content. This particular setup is not as great for summing something down to mono, if I needed to put this into mono, because of comb filtering. Because of that time difference between the two microphones, I might be in a spot where certain frequencies cancel and certain frequencies boost, so the sound that I think that I'm going to have, I don't actually have. That brings us next to the coincident pair. The coincident pair, again, uses two microphones, and these are actually directional microphones at this point. This is actually less forgiving for having ambient room sound, but it does actually give you more localization cues, and because of its directional nature. Basically you have the mics spread apart. It's shown at a 90-degree angle here. It doesn't have to be a 90-degree angle. Typically the rule of thumb is the closer and larger the instrument or the thing, the sound source that you're trying to mic is, the wider that angle is going to be. And that is that's basically the coincident pair. We're going to actually set up all of these in the other room. And then we have mid-side, which is actually my favorite. The mid-side, and this one's, it's my favorite because it's a little bit tricky and you kind of feel like a wizard or a genius when you use it. It uses an omnidirectional microphone directly on axis, and that provides the mid signal. It uses a figure of 8 microphone pointed off axis, and the figure of 8 microphone basically picks up on each side of it and not in the middle, just like its name sort of implies. We see the eight. We see the eight there. Channel 1 is the mid microphone, and that's pointed directly on axis with the with the intended source. Channel 2 is the figure of 8 microphone, but it is panned completely left or hard left, and channel 3 is panned completely right, hard right, and it's also polarity inverted. So what this means is now I have a stereo setup where I can actually vary at the console or later after I've recorded it by changing the level between the mid and the side, the width of my stereo image. All the other microphone setups that we've set up so far, we spend some time in the studio or on the stage placing these microphones, and we come up with what we think is a great stereo sound, and we're stuck with that sound. The other benefit to the mid side is that it's the only situation that we've talked about so far where you actually have a mic pointing directly at the sound source. All the other stereo configurations that we've talked about so far are actually using the off-axis response of the microphone or as a rejection part of the microphone to actually pick up the sound source. So now we have less level, which ends up giving us some more reverberant and things like that. But the mid side gives us kind of the best of both worlds because we have the sides adding to all that reverberance and things like that, but you also have the mid picking up the actual signal. So we can probably go back to Logan. And Logan, we can go through one of these setups. Do you want to start with? Well, we just talked about mid side, Paul. Do you want to start with that? So why don't we, as Logan sets up there, she's going to. Are you going to play the cello or the mandolin? The mandolin. Okay, perfect. Logan's going to play the mandolin. And Paul, why don't we start with, and what we're going to do is we're listening to these microphones. This is an exercise in talking about mic placement and mic techniques and stuff like that. It's not an exercise in EQ and mixing and things like that. So we're going to leave everything flat and we're just going to listen to what the actual microphones are doing. So, Logan, how close would you say you are to that?
Like 6 inches.
Do you want to go back to like maybe like do you have space to get back like maybe another 6 or like another 12 inches?
Yeah.
Perfect. And then Paul, if we could have just the mid mic. And then as she's playing, you can blend in the side mics. And that should add some width to the signal. And so you were blending that in there. I can't tell from up here because I'm behind the speakers and. Mm-hmm. And then is everybody hearing that difference of the widening? I can't tell from here because I'm not in the localization field. And to be honest, to be fair, none of you are actually in the optimal position for hearing full stereo. You'll be able to hear left and right, but none of you are actually sitting center. There's a center aisle, and none of you are 30 degrees off axis from each speaker. But even in a room like this, we're not mixing a record in a control room. But even in a room like this, you're able to hear that mono source. It's an instrument in a room, but you can hear it get wider and bigger and hear a sense of the room and the space that it's in. Logan, do you want to add the 4099 to your setup?
Yes.
So the 4099 is a clip-on microphone, which so now we're going to talk about doing some close miking. Um,
Just a second.
no, that's okay. Actually, we can switch back to me for a second. And while she's setting that up, I wanted to show this. When we right there, we used we used a product. The first product that we used that was not a DPA product so far, which was an AKG 414, which is a fantastic mic, and that mic has many different patterns. One of which being figure eight, and that's how we were able to capture that figure eight sound. If you do not have a figure of eight microphone, but you want to get figure of eight characteristics, you can do kind of what we talked about in the mid-side scenario, because that's actually what's happening in figure eight mics. They're actually dual capsule mics. So I can actually take a pair of directional mics like this, cardioid mics, and I can put them into a mixing console or a matrix or anything like that, and I can invert the polarity on one of them and then pan them hard left and right, and that would also give me a figure of eight pickup pattern when it comes out. I also threw in here that if you wanted to do this, but you also wanted that just on one channel, you didn't want to deal with that in the console, you can actually also cheat by passively combining those things. You can take a summing Y cable, put both of those microphones into the summing Y cable, have one side of it pins 2 and 3, which are the which inverts the polarity on that side, and you'll end up with the same result there. Logan, you ready? Perfect. So now we have Logan with the 4099 not staying in place. Or did you want to do it with the cello and we can come back? Because I think I think we tried it on the cello. We tried this earlier with the cello clip, so I've kind of put her on the spot there, trying to get it onto the mandolin. We'll come back to Logan again. We talked about on and off axis frequency response. We talked about fast transient response, and we talked about SPL and dynamic range and the clipping point when we're talking about attributes of choosing a good microphone. Yep.
You want all three of those? Like if I have a high SPL, but I don't necessarily want to go off axis linear, can I still have a good mic?
You can, because there are so many different applications. I might need a high SPL mic. Sorry.
Can you repeat the question just for the live stream, please?
Oh, I'm sorry.
Thank you.
Okay, so the question was, do I need all three of these things to have a great microphone? These are three things that make a great microphone, but do I need to have all three of them to still have a good good microphone? And my answer is basically it has to do with the application. If you are recording a single sound source that is very loud, like the takeoff of a, well, I was going to go further than that, but I was going to say it's a takeoff of a jet engine, then the number one attribute that I'm going to be looking for in that microphone is SPL. I'm not necessarily looking for high transients and fast transients. I'm not necessarily looking for off-axis response because, quite frankly, I won't be able to hear anything else other than the jet engine. So your point's actually really valid there. A lot of these things depend on application. When we were looking through, every DPA mic is a condenser microphone. When we were going through the different types of microphones, some of the microphones had different characteristics. We looked at a ribbon microphone that had, if I go back to that, had very, very good high frequency response, very, very good sensitivity, does not do SPL very well, does not handle any movement of any kind very well. I can basically break some ribbon mics by by dropping them. So that might be a mic that I use in a very controlled environment to record something that is very high fidelity, and that might be the important thing in that recording, but it'd be a very poor choice to put that mic on a rock and roll stage. I think the condenser microphones, and shameless plug going back to the DPA microphones that I represent, is a very good balance between all of those things, where we are able to have a product that's both rugged and high quality and high SPL, all in one product. Let's check back in on Logan. All right, so okay. So Logan has. Do you still have? Sorry, do you still have the mid side set up though? So what we're gonna do is we're gonna listen to Logan play the. We're gonna listen to Logan play the cello with the 4099, which is a clip-on microphone. And then we're going to blend in the mid side, and then we're going to talk about something. We're going to talk about time alignment when we get there. So Logan, go ahead. So Paul, if you give me a little bit less level on Logan, because we're also going to blend in the other microphones as well. So Logan, if you do that scale for me again, and then we'll blend in the mid side, and we should probably hear that we have a little bit of timing issue. Okay, and then can we do one more time, but just with the close mic, just with the 4099, just to give everybody reference? Okay. Thanks, Logan. So what we heard was we were probably happy with that 4099. It sounded like a violin, sounded great. We added the mid side, and it turned into a whole other world. I have a room, I have width, I have stereo. It brought that whole violin to life just by summing those two things together. And with the close mic, I got some proximity effect, which gave me some of the depth, and gave me some of the bowing action that I wasn't able to get from far away. But the life really came from the stereo microphone. It gave me the impression of being a little bit further away from the instrument. The other thing we can do is we can go back now, and we can actually, that mid-side microphone setup is further away from, that mid-side microphone is further away from the instrument than the 4099 is. We can actually now also correct the other issues that we talked about, timing, by delaying the sound from the 4099 till it gets in time with the mid-side microphone. And as Paul turns the delay knob up by just a few milliseconds, we'll probably hear the whole thing get even fuller. So maybe we can try that again. Logan, if you're there. So sorry, Logan, one sec. So what we're gonna do is we're gonna go. We're gonna do the scale, and let's have all the mics involved right now, the 4099 and the mid-side setup. And if you find a balance between those, then what we're going to do is delay the, we're going to let her do one pass with that, and then we'll do the second pass, and you're going to delay the 4099 till it's in time with the mid-side. Okay, stop there, Logan. So Paul, Logan, how far would you say you are, just scaling from the video? Would you say you're probably 3 feet?
Between 2 and 3.
2 and 3 feet. So why don't you add 2.5 milliseconds to that, Paul? To the 4099. And then halfway through the scale, punch the delay out. Logan, you can keep playing. Okay. So, was everybody able to hear there where we punched it? Oh, okay. Did you actually? Oh, okay. Um, you know what? I'll do it with my hand, and maybe give me a little bit more 4099. Were we able to hear that? Okay. Yeah, it is small in there. 2.5 milliseconds is pretty short. Okay, I'm gonna abandon this. Sorry, that might be a too small room to do that in. Um, yeah, it's subtle. So, that being said, we have a very small room over there. The larger the room, the more space there is, the bigger that difference is going to be. So basically, just going through the techniques of getting that microphone to be in time with with the other mic. So now um, we have Logan uh, in the in the room with we have a drum set in the room, and we have a kick drum microphone, and and that's why that's in the other room, and we're way over here. So if we get Logan to go to the drum set, and we can have our camera operator frame that up. What we're going to do is we'll have Logan do a few kicks, and then we'll have the kick drum mic. What we're going to do is we're going to play with the proximity effect by moving the kick drum mic further into the kick, further out of the kick, further into the hole, pointing at the beater, pointing back from the beater. So again, no EQ, just basically looking at mic placement here and how the mic placement changes the sound. So we can start there. You don't have to play a beat. We could just do the kick drum. Just and then let's move the kick drum. Let's lose the 4055 a couple inches closer. Sorry. And then you could actually just stay there. And then as she's kicking, you can keep kicking continuously. And as she's kicking, we can actually move the mic even closer into the hole and point it at the beater. Okay, and then nope, don't move. And then we can back that mic up right so it's right at the entrance to the hole. So as we're at, thanks Logan. So basically what we're trying to demonstrate there is as we're moving the microphone, the first thing we should be looking at before we go grab EQ, we're able to, when that microphone was further away, we had less low frequency response. As we got closer, we got more low frequency response. As we got in the drum and pointing towards the beater, we got a little bit more high frequency. sometimes we want to look at some of these things before we grab for EQs that can be a little bit more destructive. We have when
Can I ask a question?
Yep.
So for the room, Adrian earlier on talked about proximity effect, and we're seeing that, and we're seeing how close we're getting it to the source and the different parts of the instrument. But what about the off-axis? How is that playing into things?
Oh, perfect. So with the actually, if we look at this, actually, let me go
Because
here.
a drum is an interesting piece. Once you start pushing that mic into there, then a whole bunch of weird things are going on at the same time.
Right, and you're getting closer. This comes back to the whole conversation about our panel discussion with different people on a panel with live mics. A drum set is very much the same thing as that, whereas the off-axis response of a microphone is just as important for the on-axis response, because the off-axis response, depending on where you place that kick drum, is also going to hear, if it's out a little bit more, it's hearing some of the cymbals, but so was the overhead mic, so was the tom mic. And all of these signals are combining together. So that just gives us, that just makes it more important to have good off-axis response. So what we're going to look at is, sorry, one sec. Oops, I hit the wrong button there. Here we are. So here we have a lav mic like that panel, not unlike the drum set, not unlike the panel, but just a lav mic on a person's body that can go into different spots. When we put this lav mic at different spots on the body, it has a different level of gain, but it also has different frequency responses. So all of these off-axis responses need to have the same characteristics to be able to sum together correctly. So even with the different obstacles, like the person's chin or the person's ear or the microphones on top of their head, we're actually able to sum different microphones together. Same thing happens on the drum set. So now I have a hi-hat mic, I have a snare mic, I have a tom mic, I have overhead mics. Having the same off-axis response helps us there. How can I say this? Sorry. Maybe we'll just move back to see if there's any examples you guys want to see from the studio. We have a drum set with various mics. We've talked about a few different stereo miking techniques. We do have the Omni mics set up so we can do the AB. We do have the coincident XY. We've only played with the mid-side so far. Is there a specific instrument, the mandolin, the cello, or the drum set, that we'd like to see any of these microphone setups in? Oh, great. Logan, can you get the lav mic ready, the 4061?
Is everybody familiar with the reason why you're going to put a microphone on somebody's forehead? We no, that's a good question. Why on earth are we doing this? Why are we putting Adrian, you want to get into that a little bit? Well,
yeah, I'm sorry. So a lot of times we see a microphone in a certain application, and that's the application we learn it in. And Sometimes we forget that not everybody has seen this microphone in this application, and the different places that we showed the microphones being able to be placed is this one in particular is mostly used on stage for Broadway for theater. They basically call them wig mics. Sometimes they have them with a very short cable. Yeah, and we we could have them on a very short cable and actually have the transmitter in the wig. So oftentimes when multiple players are playing different parts in a production, that wig mic might be part of that wig, but that wig might be part of their costume for when they're playing this character. So it's very easy for them to get off stage, do their quick change, grab this wig and put it on, and have that sound right there. Take that off, go off stage over here, put on another wig mic, and have that experience there. So, sorry. Any other questions or comments about that?
Yeah, Neil Peart of Rush back in the 80s. Am I hearing something there?
No, it's just I'm thinking about a lot of drum mics. We're gonna have the question answer mic just because we have a stream as well, so we want people to hear you.
Yeah, Neil Peart back in the 1980s.
Yeah.
When they were doing the Moving Pictures and Signals albums, he actually had a mic strapped to his chest.
Yeah.
And his comment, and I tend to agree with it, as a drummer, you do not hear what the audience hears. It can be quite different. It's quite radical when you get someone to go behind your drum set and you go out front. That's not what I hear. Whereas sometimes it's nice for the audience to actually hear what I'm hearing. So would that be a case then that this would be a reasonable situation to use either a chest mic or, as you're saying, a head mic here in a different application, but just to allow the audience to hear it from a very different perspective?
You could absolutely do that. What we'll do, the thing with using a lav mic there, there'll be a couple things that won't translate as well. One will be the stereo image because it's only a single microphone. So that would be the biggest part of me not hearing it as Neil did, because I'm not here. I'm in the position, but I don't get the localization that these mics are to my right, or sorry, these drums are to my right and these drums are to my left. The other thing would be a lot of times, depending on what we are looking for in an end product, that single lav mic is not going to sound like the typical rock or pop albums that we want to sound that we want to get the sound of, because a lot of times we do a lot of signal processing, which gets into a whole other conversation, but we do a lot of signal processing on a whole bunch of different mic chains. So the kick drum, by the time we listen to it on the record, does not sound like the kick drum. And sometimes that's on purpose and sometimes that's not. I think one of the great things that we've been able to do with some of these miking techniques, and maybe what we'll do after Logan uses this lav mic, maybe what we'll do is we'll set up maybe the coincident pair, the XY pair, behind the drummers and let her play a beat, and we'll spread that stereo so that we can actually hear stereo from the drummer's perspective. And another thing that we've gotten, we went from mono to dual mono to stereo, and now we're into 5.1 and Atmos and a whole bunch of other things. And people, microphone manufacturers are on top of that as well and keeping up. So now we not only have stereo miking techniques, but we have multi-channel miking techniques. We have multi-channel microphones. I was not able to have one here, but we actually have a 5100, which is a 5.1 microphone, which basically looks like a bicycle seat. It's pretty big, and it basically has 5 capsules around it and uses the proximity effect from the 5 capsules and gives you the low frequency as well. So now you have 6 outputs out of this one microphone on a multi-pin connector. It's really great. Logan, are you back there? All right. So right now. Actually, Logan, let's if you hold that microphone in your chest position first, like just right against your chest.
Sorry, just repositioning.
Yeah, that's okay. And then we can have you say a couple words. We could have you maybe say a couple words or a nursery rhyme.
Just test 1 2 1 2. Unfortunately, the audio in me goes hard. That's all I'm allowed to say.
That's
Test
okay.
1 2.
Can you then put the microphone at your ear as if it as if it was just hanging over your ear as well?
Yeah. Test 1 2 1 2.
So
Testing 1 2.
we have a lot less level. Paul, can you turn that up?
Test 1 2 1 2. Testing 1 2 1 2 3 4.
So depending on the application here, if I'm sorry. Oh, you can hear the noise. You can hear the noise floor go up. We've just done a lot of gain, but depending on the application here, if I'm in a PA situation, this probably won't work very well if I'm trying to fight gain before feedback, because as I turn it up, things might be feeding back. I might have to be using things like EQ to try to fight that feedback. She's in a totally different room. We can actually get away with this. We can actually now, if you could put it in the head, like the wig position.
Something kind of like that.
Yep.
Test 1 2 1 2. Testing 1
So
2.
this position, it's quieter, but it's the most natural. I don't have the obstructions from from the bottom from her neck, from her chin, sorry, before the sound gets to her mouth. If I'm in Broadway, then this actually works to my advantage. I usually don't have to get to the sound levels that I would have to get on a rock and roll show. So it works for me really well. If I'm in television, this works really well. So if I'm trying to record a movie where we don't want to see microphones, we want the actor to sound as natural as possible. This is probably the very best position we can actually be in. Not necessarily a great position for a live sound. So Logan, if you could say a couple more words and then put it back into the chest position and say a couple words just so we can get a contrast between the two.
Yeah, for sure. So test 1 2 1 2. Testing 1 2, and then we'll bring it down here.
Sorry.
Test 1 2 1 2. Testing 1 2.
So
1
it's much more natural in the wig position.
If you're not familiar with this kind of microphone technique, a great example is if you go to Disney Plus, check out the live recording of the Hamilton show. Everybody on stage is wearing a microphone in their wig, except for the people who are bald, and they're wearing earset microphones. And it is interesting because you can see the mics if you're looking for it. If you're not looking for it, then you don't even pay attention. But you can hear slight differences in that live recording of this Broadway show. It's pretty interesting. It's worth checking out, that kind of thing. The other thing is we've got great clients here in town at the Grand Theatre who do this kind of application all the time, as well as we also work a lot with Stratford, and we work with Adrian a lot with Stratford, and they're using microphones like this all the time in this kind of application to be able to hide mics and be able to get great diction and intelligibility for their actors on stage when there's a lot of different things going on at the same time.
Yeah, that thanks, Carl. That's pretty much there. What we can do, do we have the coincident pair ready with the drum set? If there's a way to actually put them, like in your perspective, like as close to you as possible, Mike, pointing towards the drum set, and then this is going to go to your comment about being from the drummer's perspective. And then Paul, what I'd like to do is what we're going to do is we are just going to start with one of the two mics of the coincident pair, then we'll go to the other mic of the coincident pair, and then we'll put them together. So if you do the one mic, pan center, the other mic, pan center. So we're just hearing a mono feed of each mic, and then we'll switch to the coincident pair, panned hard left right. And I think what we'll find is you know, a decent sounding drum sound come from each of these microphones. But once we get to the coincident pair, we're going to open it up into a much wider experience. Go ahead, Logan. So you're on the first mic there? Yeah, I just switched mics. Okay. Keep going, Logan. Okay, and stop there, and then let's give Paul a sec. No, stop, Logan. Let's give Paul a second to hard pan and give us both mics now. And go ahead, Logan. Okay, thanks, Logan. So, Paul, tell us, did you you didn't adjust any level, and you didn't change any gain or anything, no EQ, but we've summed these two sources together. So, granted, there are two sources, but we seem to get a lot more level and a lot more fullness, and pulls the width apart simply by having those mics in a XY orientation, but not even necessarily pointing right at the drum set, but getting a bigger feel of the whole room. So that's part of the phase and the localization that we get there. Anything else anybody wants to try or look at? Catchbox?
This thing's cool.
I love the box.
I've never seen this before. This is sick. Going back to the mid-side, the technical setup of it. Because I'm just processing. So we have a center mic and we have a figure eight mic there as well. And you said we have 3 channels.
You do. So what we did was out of the AKG 414,
Yep.
Again, brilliant microphone, we took that channel and we actually assigned it twice. Paul has a fancy digital console, and he's able to take that mic into 2 separate channels and treat each channel separately.
So respectively, it's taking the either side of the figure eight. Then because of our panning, it's taking advantage of either like the front end or the back end. Am I getting that right? Or because it's sending one signal, am I right? So
yeah. So the reason why we pan them, each of those 2 signals, hard left and hard right, but then we polarity invert them. We polarity invert one of the 2 sides, and the reason we polarity invert one of the 2 sides is because when we add the positive swing of, let's say this speaker is the microphone and you are the sound source, the mid mic is pointing at you. When I add the positive swing that's on this side to the positive swing of the arrival of the sound wave coming from you to the mid mic here, that's additive. On this side of the microphone, because this is a positive swing, this is actually a negative swing. So when I add this negative swing to this positive swing, that's going to cancel out. So let's assume this side is the side that I've panned right, or from camera's perspective, I've panned left. But I've now that whatever side I've panned the negative swing to is going to cancel out. So that's why polarity invert
Right.
that side. So now they both sum. And by varying the level between the mid and the sides, there should be an S on the end of that. There isn't, but there should be. um, by varying the level between the mid and the sides, you're able to express how much width you actually want.
Right.
We can go back to that if you want.
I might be curious just to hear that. The polarity inversion, that was the missing piece for me.
Okay.
I think I missed that. Yeah, because I think I was just hearing.
Logan,
those
if you're
two
listening
signals.
in, you can set up the mid side on instrument of your choice.
Yeah. Even the cello was great. Like I would love to hear something like that. I always love the cello.
Cello, if you could actually. Yep. Yep. That's what I'm thinking. So maybe give me a significant amount of mid, so that's a little bit over exaggerated. And Logan, and whenever you're ready, and Paul, I'll do another hand signal when you're going to flip the phase on the second channel of the mid. So right now you're starting out of polarity on the second channel. Sorry. Yes, that is what I said. Absolutely backwards though. A lot more side than the mid. Okay, go ahead, Logan. Thanks, Logan. I can't tell from here. Is that okay. Cool. Is there anything else anybody wants to try? We do have some time. Hey, what's your name?
Alex.
Hey, Alex.
Hey.
You get a thing.
Oh, it's nice. I love this color. Sweet.
Everybody can get a thing at the end.
Great. Can we try some different off-axis coloration on a snare drum, for example, like trying to catch different angles of the impact of the snare drum?
Yeah, let's do that. I think you had an Audix i5 in there on the snare drum. So what I'd like to do, Logan, is if you can start with if you adjust that microphone, so it's about a half inch off of the drum at the rim, pointing straight down, so the grill of the microphone is parallel with the skin of the drum. Yep, perfect. And then, so give that a good crack, and we might have to have some assistance from our camera operator as well. Go ahead, Logan. Okay, and then can we actually do that again? And then immediately after, let's tilt the mic so it's pointing towards the center of the drum, and then do that again. Okay, and then what I want to do is I want to back the microphone away, and I want to put it so it's basically miking the side of the drum from about a half inch away, like physically the side of the shell of the drum. So yep, down there.
Does anybody know what that mic is?
I said the name. Bonus points.
Audix i5, that's right.
All right. I'm not gonna throw this.
Yes, please do.
Oh yeah? Okay. I'm gonna try. Careful. Nope. All right. Let's do that. So, what we're gonna do? Actually, Carl, can you do me a favor? You're Carl too? Okay. Can you bring this microphone to them
Yeah,
as well? And then what we'll
absolutely.
do is we'll combine the two.
Sure, what do you got?
This is a Beta 57, a Beta 57A,
Beta 57.
and we'll leave the Audix i5. What we're going to do is we're going to put the Audix i5 under the drum, pointing at the actual snares, and then we'll put the Beta 57 on top of the drum, like our first example. And this is typically what you would see on a typical, rock pop drum setup, but we can actually listen to it in a controlled space away from the drum set and do some changes there. Oh, sorry.
Where do you want this plugged in?
Paul? The next channel.
It's plugged into 6
Okay.
on the snake.
Perfect.
And Adrian, where would you like it pointed?
So we'll point it like how the first example was at the top of the snare drum. And then yep, that's perfect. And then what we're going to do is Paul, you'll let me know when you actually have that microphone. Carl is tapping it. Perfect. So Carl, we have that microphone. So if you hold that there, and Logan, if you play some drums, just the snare drum, Paul, let's just hear the new mic, the 57, the top by itself. And then let's hear the bottom by itself. Total different sound. Let's combine those two sounds together. Keep going, Logan, please. So, by having those two very different sounds, even Neil wouldn't hear that snare bottom sound from his position of playing the drum set. He'd never hear that, but that's a sound that we use a lot in rock, in modern rock and modern pop, and we blend those sounds together to get this bigger than life sound. What I'm going to get Logan to do is, Logan, if you do that little bit of a drum roll again, what we're going to do is we're going to get Paul to invert the polarity on one of the two microphones, because now these microphones are separated in space. So they might be canceling at some frequencies, they might be summing at some frequencies. Whenever you're using multiple microphones that are very close to a similar source, this is something that you want to check to see if you like the sound of both of the microphones in normal polarity, or if you want to reverse one of the microphones. So let's go ahead with that, Logan. Keep going, Logan. Sorry. There you go. Thank you, Logan. So you can see that literally by reversing the polarity, we completely changed the tone of the combination of both of those mics. Which mic were you reversing? Okay, so what we're going to do now is we're going to just listen to the bottom microphone and then do the same reversal and see what happens. Just the bottom mic. Okay, and that's okay. Keep going, Logan, sorry. And reverse. And reverse. Thanks, Logan. So, So nothing happened, which is what we expect because we've reversed the polarity of the signal, but it's not summed with another signal that it's changing against in reference. So we didn't audibly hear a difference. But when it was summed with the signal from the top drum, from the top microphone, we were able to hear a huge tonal difference when we reversed the polarity of those two things. So that's an example of polarity, but that's also an example of off-axis response. That top microphone is in a very different response space than the bottom microphone, so now we need to do some correction. We could have done that with phase, which takes 180 degrees out of polarity. We could have done that with delay as well, because chances are it's not completely 180 degrees out of polarity. It's somewhere in between. Back before we had fancy digital consoles like our friend Paul has, we only had polarity buttons. We did not have, so we could reverse the phase, but we did not have a way of actually delaying one input against another input. So now that we can do that, we can even closely more dial that in. So basically, I want Logan to do that one more time, and we'll get Paul to listen to both microphones, and then Paul, if you just spin the delay of one of the two microphones back and forth, and we should be able to hear the tone change as we do that as well. Just keep sweeping it back and forth between, like, say, 0 and 6 milliseconds or something. Cool. Anybody else? Cool. I think that's actually a good spot to wrap up our microphone talk. If nobody else has anything that they want to try, I hope it was helpful. I hope it was a good introduction to how some of these microphones work and how they were how they could be useful to you. And I think we will throw it back to Carl. Hi, Carl. Welcome back.
No other questions? Anybody?
Oh, okay. No, please. No. Ooh, the catch box is coming.
Oh, great. Yes, yeah, the Mises box. On my drum kit,
Yes.
I play in a lot of Rush tribute bands, a lot of progressive playing. I've mounted all my microphones inside my drums.
Okay.
I mentioned that to one of my professors, who then said, "Oh, you don't want to do that." But I thought that there was a lot of positives by putting it inside the drum, because then I've got isolation to it.
Mm-hmm.
I may not be getting the bottom head as much. I'm getting the top head more because of the way that I have them set. What are the disadvantages to me putting them inside the drum as opposed to having them close mic'd on top of the drum?
So that's very interesting. One person's disadvantage could be another person's advantage. So depending on the style that you're going for, an advantage that you pointed out is isolation.
Yeah.
But that could also be a disadvantage, because a lot of some engineers look at a drum set and look at a collection of drum mics as this microphone is the snare drum is miking the drum set. If I hit the snare drum, it hears this. If I hit the snare drum, the snare mic hears that the loudest, but it also hears my ride. It also hears all the rest of my toms and all of that stuff. And the way that these sounds combine together are a part of some people's sounds. Myself personally, a lot of my snare drum sound is actually derived from the combination between the snare drum and the overheads. By having the microphones inside, you're getting a lot more isolation, and you can dial up that drum do all the scoops and boosts that you want to do without negatively impacting. What you're actually doing there is you're making it so that the off-axis response is not as necessary to pay attention to because you're eliminating the off-axis.
Yes.
Which is great, and that can be good for your sound. A disadvantage could be that you don't have the sound of the space around a drum set. All the you're hearing individual elements as
Could you not use your overheads then to balance
to glue
that
it
out?
all together. Absolutely.
Yes.
Absolutely.
And then I've got the beauty of the control of the drum,
Yep.
but I've got the overheads as the overall feel.
Yep.
And again, I'm not trying to be difficult here.
Nope.
I'm just curious because again, the response I got was a negative one. I thought that was genius putting them inside there. And it's interesting because the snare drum's the only one I don't do it with. My snare drums are
Yeah.
too expensive to do that with.
Right.
But for my drum kit itself, yeah, that's what I've done, and it seems to work well. But I was just wondering if is there any disadvantage. But you've explained it, so I appreciate that.
So we have a lot of interesting conversations with clients because we have the privilege to work with groups on all ends of the spectrum. We work with elementary schools when they're calling us right now because they've got their shows coming up for Christmas and that sort of thing, and they're trying to figure out how do we mic this, and we've got a bunch of kids who don't sing very loud, right? And then we also have the privilege to work with people like I mentioned already, like people at the folks at Stratford, or we're doing work at York University together and things like that. And we have the opportunity to see kind of this wide spectrum. And we often talk about the fact that some of the things we do are very artsy because some of the lighting things we do, it can be very artsy, and we can, you can spend hours trying to choose, do we pick with this color or this color? And we come in at this angle or this angle, that kind of thing. But often we think about sound as being much more scientific. Like a lot of the things that Adrian's talked about tonight, he's showing you the technical, this is how it works, and then if we move it here, this is the sound you're going to get, and this is why, which is really important. It's important to be able to know the why so that you can reproduce it, or know the why so that you can have this predictable thing that you can keep going back to and finding out different ways to, if I do this and then I add this mic, then what does that do? But there's still the art to it, right? There's still that piece where you say, I'm getting this sound and nobody else is getting it quite like this because I'm doing it in a way that maybe somebody says that's not the right way to do it. And if you think about, I am, believe me when I say I truly am a 4 when it comes to microphones and recording and all that kind of thing. Many of you in this room have spent way more time messing around with microphones and moving it this way and that way and playing around with it. But if you think about some of the most iconic sounds on albums over the last 100 years, a lot of those most iconic sounds are done because somebody did something that they weren't supposed to do it that way, right? So if somebody says, I'm going to try putting a mic inside a drum, including maybe your snare, then, and that's getting the sound that you want for that specific thing, then that's cool. Give it a go, right? As long as it's predictable, as long as it's something that you can, keep getting that sound in the way that you want, and that it's not, depending on the situation, it's not handcuffing you into a position where if you're recording and then you want to be able to do something with it later, or if you're in a live application where now you can't get some things out of that input because you've got it so squashed down, you're never going to be able to get some of the, say, the brightness that you were hoping to get out of that mic because you've done something with it. I'm just using words. I don't even know what they mean. But if you give yourself the opportunity to get what you need to, then you can start, you can do some pretty cool stuff. And that's the side that I think is really neat about this, because there is that scientific math that goes along with microphones and sound in general. And then there's the art side, right?
Yep, absolutely.
Which makes it way more exciting than talking about ClearCom. But yeah, there's some pretty cool stuff.
There is some pretty cool stuff. One thing I will say is you are going to get a very different sound.
Yes.
by having the microphone inside the drum. And again, a lot of this is some subjective, and through my years of putting mics on things and mixing them and trying to please people, some things that have pleased certain people. I remember my first forays of getting into jazz and getting yelled at for using a reverb, because that's not a thing that happens there, and I was naive enough to not realize that. So there's a lot of different nuances to what people expect, to the sounds that they are wanting to hear. And if you're getting that sound in that way, I think the most important thing is to understand what some of those implications are, and you're basically eliminating, you're creating a barrier around that microphone. You're not creating a low frequency barrier. You're probably still hearing just as much kick drum.
Yep.
You're probably still hearing the bass player that's like 4 feet away, but you're not really hearing your hi-hat.
Right.
You know what I mean? So now that sound that's coming into that microphone is a different sound than somebody pushing a fader may or may not be used to. So it's just something to be aware. And then the other thing to be aware of is just you're also creating a very small reverb chamber. So before we had things like reverbs that were effects and digital and inside consoles like our friend Paul is using, we used to have reverb chambers. That's why there's a chamber reverb, which was an actual room that we would play the sound into one end of the room and put a microphone at the other end of the room and take that sound, and that's the reverb that I'm adding to this record. You're creating a very small reverb chamber for each one of those drums. So if your mission is to create a space that it sounds like these drums are all in one space, you're kind of creating all these different spaces. Yes, your overheads help to glue them all together, because your overheads are picking up the entire drum set. They're not just cymbal mics. But those are just some of the implications that you're just looking at in that case.
Thanks.
Does anybody else have any questions? Question in the back? You're not sure? Yeah,
Ready?
sure. Mike's coming at you. Yeah.
So, essentially, you mentioned the 5.1 microphone earlier, the bicycle seat thing.
Yeah, am I online?
It's it looks kind of like a pillow,
Okay.
a throw pillow.
Does the whole
Different than a throw microphone.
Yeah. Does the shape of it and the placement of the capsules help to create the surround kind of application that you would get from it because of the timing difference between the different capsules, or is there a different reason that I'm not getting?
So it really does, and I wish I had one here. I couldn't have one here. I have spent some time just literally playing with this microphone in my kitchen, and as nerds do, and I spent some time listening to each channel of the microphone. I'm just trying to see if I can get online and show you a picture of it. Thanks. When you turn this thing and actually talk into each one of the elements, it's actually pretty incredible how when I'm listening to this channel, but say I'm listening to the front left channel, but then I turn the microphone so the front right channel is facing me. It's amazing the rejection that happens. So that microphone is really only picking up things that happen in that area. And we do another, we distribute another product called Clang, and this is a little bit of a tangent, but it ties in. And what Clang does is it's an in-ear monitor system that allows you to use those arrival times, those things that we talked about, delay time between your right ear and your left ear, frequency shading, all of that stuff to tell your mind that this object is in this space. I've been able to take that 5100, which is up on the screen right now. Carl just showed it to me.
It really
I don't even know why we're looking at the picture. I mean, look at that thing. It could be a rock.
Yeah.
It's
It kind of, yeah, it kind of looks, if you looked at it from overhead, it's kind of like a bicycle seat. But I was able to have that at a demonstration in a room and have somebody talk and walk around the microphone while they were listening and claying, and the person in claying could actually pinpoint where that person was walking around them. So that's how isolated that product is.
Is it battery powered?
It is phantom powered. So every
No, like, sorry, that's not what I meant. Is it like you? Never mind. That was a dumb question. Never mind. I'm seeing no cables attached to it, but then I'm realizing it's a picture of. Just
honestly,
the microphone.
any question about this microphone is a worthwhile question because when you look at that thing, it really
it looks
like
like a Bluetooth speaker.
kind of. Yeah.
It kind of looks like a Bluetooth speaker. The underside has a multi-pin LEMO connector
Gotcha.
that
Okay.
fans out to 6 XLRs.
Okay, thank you.
Yeah, no problem.
And so the next question is so how many channels do you need phantom power on?
All. I'm not sure if you need Phantom on channel 6. I've not tried
It
not
makes sense
phantoming
you
it.
don't, but
Yeah, it makes sense that you don't, but
last channel a dynamic, just like for sub, or
it's actually taking from the other 5 channels.
okay, it's summing them, or
Yep, and it's basically I'm going to claim the ignorant card here because I'm not sure exactly how it goes together because not only does it sum them, but you only hear it low frequency out of that output. I'm actually not sure how that's happening.
does anybody else have any other questions? Oh, up here. Here comes the mic. There you go. Oh, there was a question about how does the mic work?
That's a good question.
It's a lavalier microphone. There's a standard Shure belt pack inside of it, but there is something happening between the belt pack and the lavalier microphone, and that is that there's an accelerometer in it. So when the mic starts moving, then the mic mutes. Okay, question.
So cool. Yeah, I was gonna ask more about the application for that microphone that we're talking about here.
This one?
Is it used mainly for like kind of room atmosphere events? Is it more like?
It has been for I have some people who do some sound design and sound recording for atmospheric stuff. So I've had a person take some of the 4061 lavs, like what Logan was wearing when she put it on her head, take 24 out of them and space them out over a long space and record a train going by. In that microphone gives you a very good sense of space. So I've seen it mostly used in broadcast. We used them with CBC on the Junos a couple times. They actually own a couple of them now. I've also seen them used with bands set down in front of the stage as the in-ear monitor, as something that goes into people's in-ear monitors when they're using clang. So now with their ambience mics, this is tangentially related to microphones and localization. But if I have a band on stage and I have a couple mics, maybe one close to that PA speaker and one close to that PA speaker, pointing at the audience to pick up the audience so I can feed it into the band's in-ears so that they can actually hear some ambience and hear what's going on. It could be very disorientating because the localization is spread so far apart. Having that microphone more center and in front of especially maybe the lead singer who is also center, he's or she is able to actually tell if that sound is coming from over there or over there or over here. If I have a microphone that's over here in this area trying to cover the room that way, if Paul were to scream over there and this microphone picks it up, I would be standing over here and that microphone signal would be routed probably by the monitor engineer to my right ear. It would sound to me like that sound's coming from over there somewhere when he's actually really over there. So I've seen some bands actually try to pick that up and use that type of use that mic for that type of application as well.
Well, it's very interesting. Thank you.
All right. Any other questions? Okay, cool. First of all, we should thank Logan for helping out because she was awesome. And if you
Thank you, Logan.
if you see her on the way out the door, you can say thanks. And thanks to Adrian. He obviously spends a lot of time with microphones and other technology as well, and he's got a lot of knowledge. So you're certainly welcome to pick his brain on your way out the door tonight. And if you wake up in the middle of the night and you've got a question, feel free to email us, and we can forward that on to Adrian, or we can try to answer it, or something of the sort. You're willing to do that, I think, right?
Absolutely.
Absolutely.
Absolutely. Thanks, everybody.
Yeah, thanks a lot for coming. Just a couple of quick things. One, you'll notice that the front of our building is purple for this month, and that is to support the London Abused Women's Center purple light across the whole city project. That is not the way that it's Shine the Light campaign. There we go. It was in my head somewhere. Yeah, we do actually change the front of our building for different things, and so it was red last night, and it's going to be purple for the rest of the month. So if you see that around town, that's what it's about. We're Horizon Solutions. We do all kinds of weird and wonderful things. If there's something that we can help you with, then feel free to give us a call, and we'll try to help you out. We have another seminar that's coming up in January. We take December off every month because nobody ever wants to come see us in December for a seminar. But in January, we'll be back, and we will be picking things up with a series that we call Resource Stage Conversations. And in Resource Stage Conversations, I sit down here on a nice big chair, and I sit down and chat with somebody who has worked in the industry for a number of years, and I talk to them about how did they get into the industry, what are they doing now, what did their path look like to get there, and we talk a little bit about what their job is like in the industry, and that's kind of cool. And for those of you who are potentially looking at what are some of the job opportunities, how can you make money in this industry? It's pretty cool. We talked to some pretty neat people. And if you're wondering, you can go back on YouTube and you can check out a lot of those sorts of conversations. Okay, some of them we started during COVID, so some of them are me talking to somebody on Zoom, and then the last couple of years we're doing them here in our office. And that is in January, the second Tuesday of January. And then we will be going back into regular seminars into February, March, April, and so on and so forth. If you have any more questions, or if you're interested in anything about any of the microphones you saw tonight, or any of the other pieces, or if you really want to buy yourself a Digico console, then Adrian would be happy to talk to you about that, and we're happy to take your money. Thank you very much, and have a good evening.